Hello, welcome to our presentation. So today I will tell you about my mini project Smart Parking. And first, our group is Team 9 Basic Programming for Electronic. So let's we will have the members of our project. The first one, me. My name is Trương Hải Minh and my my responsible for this project is about control ultrasonic sensor SCSR04, gas sensor MQ2, PowerPoint maker. Next one we have Vũ Thế Phong, who in charge of RFID servo and report writer. So last one we have Trần Đức Lương, who have the role in camera and modeling. Next we have the content of our presentation. So first we have ideas for this project. Next one, overall solution. Next we have implementation on LabVIEW, and the last one is comments and tendency. So first, I wanna tell with you that I will presentation this project layer by layer. I mean that first I will talk about some kind of layer by layer, but for abstraction level. That first about the point of view in reality, and next one we will dive more deeply about the code by LabVIEW, the principle of this system. So first one we have ideas of this project, and of course, every student, I'm gonna um, take its idea from YouTube videos that I gonna search about the top 10 project from Arduino, and yeah, this is this ideas smart parking system is one of the most suitable with us with our project because um, this actually the first project for our team, so that it will have some challenge. So that okay, this smart parking system is fine. So next one we will have solving many problems of normal car parking. At that point, I will dive into safety and convenience. So why safety and why convenient? I will have summarize something because I will explain this in the next screen. So first about safety, I think it's a most important element that that uh, car driver will choose when put their car in this parking, because nowadays we have so much problem with oil, with electronics and something like this, and this is very um, make us worry about our car, about our safety of our car. So yeah, I will explain more in the next screen. And about convenience, that in this project we just put the information up, the information state of this car, the state of smart parking system onto our monitor screen to make the god, maybe make the user know about the state of this system. Okay, so dive into this this two both of both of these ideas more. Okay, so at that point I will mix both of them together. I mean that I will talk about safety and have some kind of demonstration about from convenience screen. Okay, so first we have the first function of safety is about supervising car. So what? Okay, like I talked with you before, present on monitor is some kind of the one convenient function of our system. So about supervising car, what can we present on monitor? That about the position of this car, about position 1, position 2, and last warning. I will talk about position 1 and position 2 first. This will collect the distance from both the position. If the distance is less than I mean the distance from the sensor to this car or to this object in the in in this position. If the distance is less than 7 centimeter, it will turn on, and it's some kind of making people know that there's there's one car in position 1, or there's one car in position 2, but now we just don't have position 1 and position 2. Sorry, we don't have car in position 1 and position 2, so that we still have the announcement, welcome, we still have position. Of course, it's still quite true. This announcement still quite true for if just position 1 and position 2 turn on the light. I mean that there's car in position 1 or position 2. This announcement still exists. And about gas warning, I will talk with you after that function, right? Um, okay, like I talked with you before about the position 1 and position 2. Now we have the car in this position 1 and position 2, and the announcement might be some kind of sorry, we are running out of position. So the method, the principle that I apply to this car parking system to make the computer know whether if the position 1 or position 2 have the car or not, I will explain with you later. Okay, so now we will come to gas warning. That the next function of from safety function that we update continuously the gas level. Yeah, it's some kind of correct the concentration of gas in the atmosphere and compare with one specified amount of gas concentration. Okay, if it's over this level, the gas warning will turn on the light, and maybe it will have some announcement here that yeah, firing fire firing or gas warning on or something like this, but it will make the guard or the controller of this parking system know that we have something like burning. Yeah, this is very terrible for car parking system. And yeah, God or some people like him will take some solution for this situation. Okay, I will explain with you later. Don't worry, don't worry about the methods that computer will understand the gas level is is enough to turn off the light gas warning here later. Okay, so the next function of this parking system smart parking system is double check. So um, maybe you will wonder about what will I check in this parking system. So here's the answer for you. I will check the card ID for get into the car parking system and for get out go out the car parking system. Okay, here's the implementation. We have UID input and UID output. To be more clarified, I need to change it to UID get in UID and get out UID. You can imagine that every card will have the name for this card. This some kind of identifier for each card, each electronic card, and yeah, this array here, this number array here, 63551035 is the name of this electric card. So we our parking system will check it true or not and make the decision the car can go out the system or not. Yeah. It's some kind of avoid tipping, something like this. Tipping. Okay. So next, what will I check next? Yeah, I will show you my answer. That we will check the number plate. So yeah, this is a way that we make the computer understand the string, the number array that um, through my friend's system about using AI to process the image to get out the string here. You can see it the same with the image, and it will check in the get in and get out, and yeah, we have double check to make the decision for car to go out the car parking system. Okay, so like I talked with you before that we will dive into the more deep layer of this project that now I will exp explain with you the methods, algorithm that I have used for our car parking system. First, about implementation on reality, I will uh, show you our our result on reality to confirm to make you more clarified, more understandable to our project. Okay, so about the function of supervising car, we have here the video. Okay, so before starting my explanation, I think that I will explain some device like here with you. This is the sensor, and this will gain the input. This will gain the input from reality and take take this input in our system. And yeah, like you have seen before, that we can have the state light turn on or off to make the position, to make the people know, is there, do this position have many car or not. Okay, so let's let's do it. Okay, so now we don't have many objects before this sensor. Yeah, now I put my hand on this sensor, so you can see what happens on our monitor. Okay, so do you know what happens here? Why I put my hand so near to this sensor, but the the monitor still shows the distance is very high. Oh, sorry. This 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 sensor shows that this sensor have the function, some kind of like showing the distance between the sensor and object. It's not actually true, but I will explain with you more later, because it's not really easy to talk with you at here. So you can think something like this: the distance between the sensor and object. At here, the object is my hand, not the car. Okay, so you can see that it's still high, although I put my hand very nearly to this sensor. That is some kind of I have used the one tool that I have created to compute the average for 5-time measurement. Okay, I think that it's better to explain with you um, on the part that implementation on NavView, not now. So that, yeah, just have some thinking like this, and um, you can imagine this system like after 5 times you will gain the right the right distance, not the first one. So do you want to see that? Yeah, next one is much lower, and next one is much lower, and here you want to see, maybe it can code the right distance between my hand and this sensor. And you can see here, do you see it? The 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 net, yeah, the net will turn off to on state, and it's some kind of certificate for my condition. My condition is that I compare this distance with 7 centimeter, says 7 centimeter. So if the distance is less than 7 centimeter, I will turn on the camera, and yeah, announcement at here. Sorry, we are running out of position, but you can see it here. Yeah, it when the LED turn off, it's just about welcome. We still have position. Okay, I think it's a little bit clarified for you to understand my idea for this device. So next one, I will introduce with you about, oh sorry, about this name of this device. It be called ultrasonic sensor SCSR. R04. Okay, so next one I will tell with you about some information of device of ultrasonic sensor HCSR04. So here's the pin for this device. We will have transmitter for ultrasonic waves and receiver for ultrasonic wave, and very normally about VCC pin, ground pin, trick pin. So it not it's quite unique for this device about trick pin and echo pin. So let me explain with you the principles of this device by this GIF. Yeah, you can see this device action depend on depend on transmitter and receiver of ultrasonic waves. It's some kind of sound. It's very easy to know that it transmitter will send some sound, and when it when it's faced with the object here, it will be reflected to receiver, and receiver will receive this sound, and after that after that this device will send the time to the computer or to the microcontroller. So why? So do you wonder that why do I talk with you? This device will send the data about the distance from this sensor to object here. Yeah, here we have the formula for this. Speed of sound is just about the normal environment like atmosphere. We just have the number, the value for speed of sound is some kind around it's some kind around the 334 meter over second, and T is stand for time. Time the sound come from transmitter to the object here and go into the receiver. So that you can see that um, why why we have to divide through this formula, because this sound go from uh, this device and go to this object and go to this device again, so that yeah, it's some kind of two times for from this device to this object. Okay, I think that's good. So next we will have the other device for my project or something like mm, function for my project. So like the the pre-device, we will talk about the implementation on reality first. We have check gas concentration. Okay, so here's the video. Let's see the video with me. So now like pre-device that we have here, the sensor, and this is just in the environment with the gas concentration level is very low, so that we will don't see anything on monitor about I mean that the LED of this sorry the LED about this sensor will be turned on monitor, and after my friend put the gas put the gas level higher at here. Yeah, you can see this will be turn on after 5 time measurement on the monitor. I mean the LED. Sorry, the LED about the gas sensor on the monitor. You can see my friend put the fire producing. Yeah, maybe. Okay. Yeah, here the level gas sensor is very low. It's just about 66, and after that it will improve to 33. Next one, yeah, 154, and nice, yeah, it will be improved. And here you can, oh sorry, and here you can see it's still improved. Here, like the distance for ultrasonic 1 and ultrasonic 2, if the gas concentration level is certificate for my condition that I have given for the system, the LED here will turn on. Okay, so as you can see, but we don't have many announcement for this situation. Yeah. Okay, so the 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 device for this function is called gas sensor MQ2. Okay, so we will come to the detail for this device. Yeah, some kind of information for this device. This device have 4 pin like the ultrasonic sensor that I have shown with you before. About VCC and ground is very normal, that, and about D0 and A0 is D0 is stand for digital, and it will receive digital data from the reality, and A0 is analog. It will receive the mm, analog sorry analog information from the reality. Like you can see that when we have smoke in our environment, the output voltage will turn from small to highest point. But when in the clean air, the yeah, the output point will turn from the high to the lowest point. Okay, I think it's easy for you to understand. So next we have the nearly last one for our project about check card ID. Okay, so you can see that we have here the UID, sorry, the device to receive the data from electronic ID, and here is the next one, and we have barrier, the servo, but we in this project is responsible for some kind of barrier for the car parking system, and some kind I will introduce with you here is that this is the device for the gate. I mean the gate in that car. If the car want to go from want to go into this car parking system, they need to go through this device first. And here is a output, here is a servo to for this device, for this input device, If there's just UID at here, the servo will turn just um, around 90 degree and turn to 0 degree again. And here is device to check to do you still remember double check that I have talked with you before as a function of safety, that if the double check will be okay, this servo for output will turn to 19 degree and turn to 0. I mean the activation of turn to 90 degree to make the car can go through, and the activation to turn to 0 is some kind of close the door of this parking system. Okay, so I will implement with you here. You can see that this input RFID. So when we through, yeah, the servo will turn from this to degree, to 19 degree, and will turn to 0 after that. If we just get electronic card through this device. Okay, so we will check for the input get in again. Next we check to the output. Here you can see that if the card is true, sorry, but we just check the card now because we don't have camera at this situation. That if the card we use the same electronic card, so that the servo absolutely will turn to 90 degree and turn to 0. Yeah, you can see it. Yeah, we check again. Yeah, okay. Yeah, I think it's um, easy. It's quite easy for you to understand, and we have the name for both of this device is here, RFID RC522, and the name for this device servo motor SG90. So next we will have some information for both of device. About RFID, we have some information like this. For pinning to this device a little bit complicated, but yeah, I will talk with you after that later. But maybe I cannot talk before. It doesn't be necessary to talk with you. Just see the way it's active here. If the card turn through this device, we will have ID for this card um, is some kind of displayed on the screen. Yeah, this is the name of this card, and we call it UID for this card. And next one, we have the next device about Servo SG90. Here you can see the activation. I mean, there's no more thing to talk about this device, so that I just send you the way that that device can active. Okay, so next one, we have what? Oh, we have about checking car number plate. It's just um, applying the AI to train the camera to make the camera know this is the number 2, this is the number 9, this is the what F, and this is the number 1, is something like this. And you will see it here, the output will be returned at here, and you will see that the camera have to check it again and again to the last one, to the last, it will return to right answer, but it will take you many times, not one time. So you can see that. Oh, sorry. Yeah, it will have something like this, but yeah, at least it will return to the right array, the right string as the last one. Okay, so I think it's fine for our device at this project. I mean that there's nothing to talk about this algorithm more, because it's some kind of from the training AI for this device, so that we will like to information. Do you still remember microcontroller that I have talked with you before? This is a microcontroller that I have applied for my project, for our project. This name is Arduino Uno R3, and yeah, this is some kind of a pinning. Do you still remember it? I have talked with you before about the pinning of the device, and here this is a number from 2 to 30 is about digital pin, that from digital pin that I have referred before. And yeah, here is analog pin, analog in for some kind device, for some kind device like gas sensor. Yeah, do you remember it? Just have A0 and D0 pin for this device, so that analog will be applied to something like this. And of course digital is I think that digital is more popular than analog in mm, at least in this device, so that we will have some kind of yeah, here that I have shared with you before, but there is more detail that if we have some problem with our device, we can push the reset switch to reset some kind of code in coding in this microcontroller, and this code, I mean, we can transmit transform the code of ours through computer, through this USB to this microcontroller. Here you will see this IC, and here is about RX and TX net, that stand for receive and transmit, and it will turn on if it's true. And some kind of that I have talked with you before about the ground pins, P PWM pin, and but it's still digital pins, and we don't have the ability to access to digital pin 1 and 0. And here is about analog pin input, and some kind of ground pin, and voltage source about 3.3 volt and 5 volt, and here's the reset. And yeah, I think it's enough for our project. That's maybe it's understandable for you. Okay, so this is a pin map for our project that is a little bit complicated, but okay, I will talk about some device, just some device, and yeah, you need to search for yourself to know the where the where the pin of this device will be pinned to the the position of this microcontroller Arduino Uno robot. Sorry, Arduino Uno R3. Here is ultrasonic sensor HCFR04. Here is a servo 90, and here is a RFID RC522, and the next one is about M32 device, the gas sensor. Okay, so image of model I will show you after because I don't really have this image now. And implementation on Navier, the whole system. I will give you this data for the another video. And yeah, of course, like I have talked with you about the the form of this presentation. It will be some kind of lack of information about the is a common and tendency. I mean the commons, but I will take it into the videos that I talked with you before on the implementation of Navier that my each person, each members of my group will talk by themselves. Nice. We will have tendency that we want to improve this system by the pass for free position. Do you still remember is that we just have which one is free position or not, so that I want to apply GPS on some kind of this device, some kind of the card, the electronic card of this device to how say to GPS of this card to the free position. Yeah, it will more easy for people to find the place. And here you can see that the camera is not really good, and we need to train AI more if we want to have the better system, that more accurate camera. And solution for burning, yeah, of course I don't really have the solution for the burning, because I really want to pin the buzzer or something like making water to solve this burning situation. But really I don't have enough the digital pin of microcontroller Arduino Uno R3, and so that this will be some kind of limited for me. So, but if I have the trend, I will improve this function. And the next one that like I talked with you before about the apply GPS for the card, that combining with IoT. IoT stands for Internet of Things. That we will apply Internet for something like electronic card about the about the about the GPS. Yeah, okay. So position, the place, and this absolutely will be more flexible. That we will have online interface that uh, even the customer, sorry, even the user of this car, of this smart parking system can follow the state of their car through the phone. And yeah, maybe we can make the monthly ticket because it's real some kind of utilize the cost, the price to make something like yeah, you can see it here, saving the time because if someone who parking so much time will have to pay more money, so that yeah, is absolutely the perfect, sorry, the powerful solution for saving time. So the last one, yeah, as every project, produce, every production, we need to integrate with AI that we can guessing which time is busy, yeah, making camera more accurate. Okay, so I think it's enough for our presentation. Maybe it's still lacking some data, but yeah, I will present more for this implementation on reality that you can see it on another video. But, yeah, of course, yeah, thank you for watching and see you later. This is my team that we have some members like this, and yeah, my team is team 9 of basic programming for electronic. Thank you.